Okay, so today we're talking about describing function behavior on intervals. Okay, so a function is increasing. We can skip this business. A function is increasing on an interval when the function values are rising and going up from left to right. A function is decreasing on an interval when the function values are falling or going down from left to right. A function is constant on an interval when neither increasing nor decreasing, so it has the same y value. A function is positive when the graph is above 0 on the x-axis, and a function is negative when the graph is below the x-axis. Okay, so basically increasing is going uphill, like the slope. Oops. Decreasing is going downhill, and then constant is your flat. So uphill, downhill, and your flat. Anyways, okay, so on our cute little picture, I have given you the equation of the function, and then I've graphed it for you. So it's increasing from, so we're decreasing, vertex, and then it starts to increase. All right, so we're increasing from -1 to positive infinity, to the right forever, basically. And we're decreasing from the left forever to our vertex, so negative infinity to -1. And since the line is on -1, then it gets a bracket. So remember, we're always looking at relation to our x-axis and what numbers are happening there, not necessarily to where our point is on our y-axis. So for constant, we don't have a constant. Positive, so it's positive, the graph is positive right here, so above the x-axis here, and again above the x-axis there. This is when it's positive. So from negative infinity to this guy, -3. Now, -3 isn't positive or negative because it's on 0, so we're going to give it a parenthesis, and we can say the union of this side. So 1, because it's not, 1 is not positive or negative, it's 0 to positive infinity. And infinities always have parentheses because they're not something we can like grasp. It's not part of the line, it's just something we're moving towards. And then negative would be this section down here below the x-axis, and again, not including them. So we start at -3 and we go to 1 right here. This part of the graph is all negative. Okay, so let's do another example. Okay, for this guy right here, we are increasing, oh no, don't fall, camera. We're increasing from left and right forever and ever, so this will be negative infinity to infinity. This isn't going down because as I walk from left to right, I'm constantly going up, so increasing none, or decreasing none. Constant, again, none. There isn't a flat spot. The constant has to be like, for example, y equals 3. Like that is a consistent line here. It's constant. Positive, where we're above the x-axis, starts at this guy. So again, we don't want to include him because he is part of 0, so not negative or positive. So -1 to infinity. And then we're negative to the opposite direction, so negative infinity to -1. Okay, we're going to look at this guy. I'm going to skip the top two because it'd be better if I had graphs, and I don't have them with me. Okay, so increasing on this piecewise function. So it's a function because I have a dot and a hole, so I don't have repeating x's with different y values. That means that it's a function, so that's why it's called a piecewise function. So we're increasing from here to up here. So here we're looking at the x to give us numbers. So, and it's an open dot, so it's going to be a parenthesis 1 to infinity, parenthesis, we are decreasing to the left forever all the way to -1. Remember, we always read our graphs from left to right, so even though this looks like it's going up, it's technically not. From left to right, we would be decreasing or walking downhill. So this will be -infinity, and then our -1 on this line does not filled in, so we're going to have a parenthesis. And then we're constant from here to here, which is including -1 since there's a filled in dot, but an open dot at +1, so it gets a parenthesis. We are positive from this side all the way here. Like these are, oh wait, and then we have a break here, and then we are negative here to here, and then again from here up we're positive. So here, this whole thing is positive, and this guy is included because he is positive up here and he's not, this is 0 down here. So we're positive from -infinity all the way over to 1. And then we are also positive from 2, but we're not going to include that because 0 is not positive or negative, to positive infinity for forever. We're negative for just this cute little section right here. So that goes from 1 to 2. Oops. Okay, now we need to talk about the end behavior. End behavior is written as limits. So the limit just means like, what are we approaching? You have 3 different types of end behaviors to look at. You have end behavior that could be up, either direction, it doesn't matter, and these would be our positive infinities. You can have end behavior that would be down in either direction, and these would be our negative infinities, or end behavior that would be constants. Did a terrible job drawing this, and that will be whatever number we're at. Those are our 3 types of behaviors that we have for the end of the lines. Okay, so let's look at our cute little graph and we'll talk about the end behavior. So this is how you say it. The limit as x approaches -infinity for the function is what? Okay, so this just means what is happening on the left-hand side of the graph for the y value. Okay, so for the y value, this is an exponential curve, which means that forever on the left-hand side, this is going to be closer and closer to -2. But it will never touch -2. Well, that's pretty constant. So that's the number that we're approaching. So as we go to -infinity, then the function is getting really close to -2. And again, an asymptote is a line that we can never cross, but we're getting forever closer to. So y equals -2 is our asymptote for this exponential curve. And then the limit as x approaches positive infinity for the function is positive infinity. So what that means is that as we trace the graph from somewhere to the right, we are going up, we are gaining, and up means positive infinity. So x to the right, so that means this direction. What is happening with our y? Well, our y is going up, so that's a positive infinity. All right, if we wanted to, just so that you could see, we could look at this graph here. And usually you would have like a connection, but it's totally fine. You could say it here too. So you would say for this guy, the limit as x approaches -infinity for the function f of x is, since it's pointing up, would be positive infinity. And then again on the right-hand side, the limit as x approaches positive infinity for the function f of x, since it's going up, would also be positive infinity. Sometimes they're the same, sometimes they're different. Again, for these end behaviors, you have 3 options. You have up, which is infinity, constant, which would give you a number, so like flat, and then down, which will be -infinity. Hey, if you have any questions, let me know. Have a great day, guys. Bye.